Now that we have discussed what sort of solar load models are there in within Fluent software, let us see what is actually the solar load model. What does it mean when we say that we are going to use solar load model? For one thing to note is that it is the amount of energy radiated to the object under study from sun rays. So the aim of the solar load model is actually to capture the sun rays, the energy that is contained in the sun rays. The solar load model present in ANSYS Fluent does the same task. So it has an internal calculator to calculate the direction of the sun according to the given place and time. So the calculator calculates the direction of the sun first by using our inputs, that is the place and time and location. Then it takes the latitude longitude of a place as input to the to calculate the amount of solar energy incident per unit area in that region. So by using that location, time and day, what it does is that calculates the latitude and longitude of a place as an input. From that it gets the solar energy incident per unit area in that region of the world. Then the solar load model in Fluent also has an option to provide direct value of solar irradiation and direction of sun rays as an input by user in place of the solar load calculator. So this basically means that you can either use a solar load calculator or you can directly give the value of solar irradiation and direction of sun. There are few terminology related to the inputs as well as the results of the solar load model. First is direct radiation. Direct radiation means that the energy radiated to an object only by the direct incident solar rays. Diffuse radiation is the energy radiated to an object due to reflected rays of sun also. There are two ways to there are two types of radiated energy coming from sun. Visible radiation, which lies in the visible spectrum of the sunlight, and infrared, which falls in the infrared frequency. Now we will see some more terms related to the solar load model. First is the sunshine factor. This accounts for the cloud cover. If there is no cloud, it is equal to the sunshine factor is 1. Basically it reduces the intensity of solar radiation, which means that if there is some cloud cover, we have to reduce the heat energy that the sun rays carries, because sun rays are going to be blocked by the cloud. So in that case we decrease the sunshine factor. Spectral fraction, it is a fraction of incident radiation in the visible part of solar radiation spectrum. As the energy content of radiation keeps on varying for different frequencies, it is necessary to know how much of the radiation comes under the visible light spectrum zone. So spectral fraction is actually the fraction of incident radiation in the visible part. Scattering fraction is the amount of radiation reflected by the opaque surfaces, which is going to end up by transferring all its energy to the surface. So what it means is it is the amount, scattering fraction is the amount of radiation reflected by the opaque surfaces. Next term is ground reflectivity. Ground reflectivity includes the contribution of the reflected solar radiation from the ground as well. Its effect is visible in the diffuse solar radiation value. Sun direction vector is nothing but contains the component of direction of the sun at the given time and location on earth. Direct visible absorptivity, it is part of the absorptivity caused by direct visible solar radiations on the wall. This value corresponds to normal incident sun direction. Direct IR absorptivity, it is the part of absorptivity caused caused by the direct infrared solar radiation on the wall. Now that we have discussed inputs and we have discussed various topics and parameters related to the solar load model, different terminologies, we will shortly discuss a test case which was done to demonstrate to you how to set up the solar load model in Fluent before we end this particular lecture.